You know, it was great to hear a little bit about motivating the question of why did we tackle unstructured data. And so I thought I'd go back a little bit in the history of just what does data management look like, and how are we achieving some of these things, like what Chris brought up of how do we actually achieve such amazing results. And it really came back to some fundamental technology questions of limitations that were out there in the ways in which people were thinking about data management and how we wanted to change that up. And so I thought I'd start with a quote that really is a focus of how we think of this problem, which is everything should be made as simple as possible, but not simpler. You know, it's attributed to Einstein, or there's a couple other debates about that. But this was really our goal when we set out, is that we said, look, there's a ton of complexity in the enterprise. How can we simplify this and actually make the administration of unstructured data better? Because look, it's called unstructured data because it's the mess that you have. You know, the only real choices you've had to date to manage that data is to buy more capacity. You say it's growing, and you're like, where is it growing? I don't know. You say, I need more of it because if I don't, I'm going to run out of space and then I can't keep doing what I'm doing. And so it's key about getting the management aspect of data going instead of throwing it at the storage problem. So when I think of data management, it's pretty simple. You've got some primary information here. You have some, I call it basically a database in the middle that you then visualize and act upon that information. In many ways, I think of the problem with data management as like the ERP world or an inventory management for a retail organization, is that you have a ton of digital assets and you need a system of record of what's out there. And only with that system of record, it becomes clear how to take action and what to do with this. And so we need to go back to the basics and say, why aren't we visualizing this in a simple way? Why aren't we doing data management as how it began, of saying, hey, I've got this way of understanding what I have and then acting upon it, and whether that's archiving or protecting that data or deleting it in many cases because it's no longer needed. You know, the example of I've got 51 petabytes of data over a year old. What of that can I free up? Why is it that large? And answering those questions is key to actually enabling organizations to make change. Now, what happened over time is that we started off with this simple picture. You know, data management isn't a new topic. There was this view of being able to understand what you have and then act upon it. But if you look at those legacy solutions, as systems grew, as the density, as Ray brought up earlier, increased, which is, look, files are fundamentally not getting larger. You're just collecting more of them. You know, I think that you might see this in your own personal world of, if you look at your phone, yeah, you're taking, larger phone photos and whatnot, but you're still just taking more of them, and not just higher def ones, but the same number of them as you did in the past. And so the actual number of things you have has increased. And many of the legacy systems were based on, I'll say, a traditional database. And there's been complex requirements driven of saying, hey, how do I track tens of billions of files that are changing on a weekly or monthly basis? How do I actually get a hold of what this whole view is so I can just ask a simple query of it? And so legacy solutions that were built around scaling the catalog associated with them, or in some form of that, just expanded over time in the requirements, to the point where maybe the infrastructure for managing your data management software was starting to exceed what you actually had in unstructured data. And so that really just didn't scale from a complexity standpoint. You had a lot of, assigning, oh, this piece of software only works with these 3 systems, but I have a different one for these other 5 systems that I have. And there was a lot of messiness involved in that. And so there was a simplification that happened in the industry. And I say that, you started bringing storage is your data management. There was this idea of bring your data to me and I will tell you something about it. You see this certainly with NAS vendors and bringing analytics to the platforms that they have there. But I say it still is even happening today with cloud providers. If I am a large S3 customer, you get all sorts of features that are like, yeah, if you bring all of your data to my platform, I've got all of this stream processing I can do with it, and kinesis and loading of the data and understanding of it. Oh, wait, but it's all within just this one platform. So I have to bring all of my data to this one platform to start to have visibility of it. That doesn't take into account any of the aspects of, oh, wait, one aspect of the tooling is great on this platform, but this other platform doesn't have that. And they're not applicable across the platforms. how do I deal with this? Well, it ends up being a lot of inflexibility of, boy, I want my storage to be great at what it does. It delivers lightning performance on my primary applications. It has scaling attributes that are fantastic for the storage aspects of it. It has great operational characteristics that I really wanted. And I should be making the choices based on that versus, well, I need to see what the data is for this one workload, but I'd have to put it on a different platform to actually see that. And that's just becoming increasingly inflexible, especially when you consider that data is spread across the entire organization. It's in many different locations, in many different, sites and vendors within those locations. And then there's potentially, the cloud gets thrown into this picture of a whole nother slew of solutions that are out there. And so ultimately this tying and coupling of the data management with storage has kind of ran its course as well. Of course, there is all of these questions of, boy, it's not possible if I don't do it without storage out there. You hear things when, I think the question came up of, how can you scan billions of files out there? And I find this stuff many times just be fun of saying like, look, I am the unique and only one who can possibly do this. If you look at my background, I actually built a lot of these solutions. And I can tell you, there's nothing unique and surprising in how vendors do this, except for that it's proprietary and it doesn't apply to everyone else. And so you've got to break some of those questions down and say, well, how do I do this? And so really, when we started talking about data management and how do we actually let customers free themselves from this kind of storage coupling era that we're in, we said, get back to basics. How do we go back to that world where I have my visibility, my dashboard of all of my data, and I'm able to act upon it? Of course, this is the chummy, vendor slide that you have out there where, look, we have the solutions to go do that, but I want to describe a bit more about how. And so, this is key to how data management has evolved over time is how do we actually get to a world where we can see our data and act upon it simply within one solution that pulls this all together? And I'll tell you what the key to that is that the key to that is that you need foundational performance and scale in one solution. It's key to actually lock in the ability to actually see all your data. I'll give you an example. We had a customer who was, hobbling together solutions to say, I just need to see all of my data. It's a basic accounting functionality of saying, what do I have in my infrastructure? And they have about 40 petabytes worldwide. And it would be a 6-month effort to go and just get a single report of what is all my data out there and how old is it. Now, you're going to operate your business very differently if you take 6 months to just understand what's on the shelves. And if you could go turn around and say, hey, look, if I could answer that question every day, every week, I vastly change how I do things. And so that's what we focused on first and foremost is how do I get the scale and performance to the point where these questions become integrated in how I operate, and I'm not managing the solution from how many databases I have or where is my data so that I can actually understand what's in it. And that's what we focused on, is that we focused on the scale and performance to deliver on these core products that we have. And what I talk about this is the 3 phases of what we do out there is that first, you need to be able to capture the ground truth. You have all this data on the shelves, in NAS systems, in cloud providers and whatnot. How do I actually observe that it's all there? You might consider this agents that go out there and collect what's out there, but how do we do it in a way that is, as I say, scan faster than flash? How do we actually capture all this data in that fashion? And then
you capture data in real time?
So we can't capture it in real time because, look, you want your systems focusing on their primary workload. You don't want to be burdening them with, oh, can I see exactly what's going on right this second? But I call it near real time, right? If you can answer questions about petabytes of data in hours, that's pretty real time to me in terms of taking these levels of actions. And so it's not real time, but it's pretty dang close to it in what our customers observe. As an example of that, I mentioned a customer who had 40 petabytes of primary infrastructure spread across, about a dozen sites. And they get a view of all of their data and a full refresh of it in under 48 hours. So that is driving to what they do. Now, mind you, their daily change rate is only 1% of that, but they get a view to be actionable within 48 hours. That's pretty great. And that's better than anything that's out there right now.
Hi,
Does
Jeff.
that make...
It's
Yeah.
Karen. Oh,
Hi,
sorry.
Karen.
Jeff, so far in this, I haven't seen anything that's being discussed that is specifically about the difference between unstructured and structured data. Can you go over what we've seen so far and explain that to me? Thanks.
Yeah, that's a great question. And what I see out there, and tell me if I'm wrong. Look, I've spent a lot of time in the unstructured world, is that in the structured world, there is a schema. There is an understanding of what the structure of the data looks out there. So either that's a cataloging of what your VMs are out there, or basing that on the infrastructure of your VM infrastructure and understanding, your global footprint of VM infrastructure. Or in the database world, understanding the flow of what's going on in your databases, because you're able to reach in and understand the schema of what's going on there. It's a lot more mature infrastructure. There has been a lot more focus on the techniques of understanding that data. And quite frankly, you can get more interesting insights. You can get, in the database world, row level understanding of what's going on. And you can, in the VM world, get to this understanding of what the connectivity of applications are on a VM to VM basis. In the unstructured world, and we're talking about files and objects here, there is no higher level abstraction available. There's no way of other than saying, hey, here's a file, here's a name that it has, here's some attributes. There's nothing out there today that really focuses on that. And secondarily is that it's usually the long tail of data that ends up in file data. Is that there are folks out there who have petabytes of VMs and databases out there, but that's pretty far in the clear. But I'll tell you what, I come across hundreds, if not thousands of folks who have hundreds of terabytes of file data. If you ask folks, what is your footprint of file data? They'll say, I've got, this file data, but they don't talk about it. They say, oh yeah, it's probably 70% of my infrastructure or 90% of my infrastructure in terms of size and footprint, maybe not in terms of complexity and focus, because it's not usually your tier 1 sort of or tier 0 workloads, but it's this big problem that's just untalked about because there's not really great solutions for it. And so I just say that there's a lot more maturity in the visibility that you can get out of your infrastructure, either through something, just as basic as the vCenter world gives you a whole lot better world of what you see in your VM infrastructure. And similarly, in the Oracle world, you have things like RMAN who give you granular understanding of what's going on with your databases on a day-to-day basis. You just don't have that in a unified way in the unstructured world.
Okay, so let's talk about that unstructured world. In a lot of cases, you're going to have, let's say, S3 buckets that are labeled specifically for data collection, right? So I may have an S3 bucket that has terabytes of scientific data from satellite imagery or whatever it is, and I may have another S3 bucket that's there to collect temperature data or sensor data from IoT devices. I know what that is already. So how does your product help me in that case?
That's a great question. What we find this to be is this, I'll call it a gap between those who are managing the infrastructure and those who know what's going on with the data. Is that if you ask the right person what that random bucket is in your cloud account, they will know what it is. But if you ask the billing administrator what that bucket is, they'll say, oh, somebody forgot to tag it. It's not right because somebody forgot to go in and tag it. And so what you need is a light to shine on where are the things that you don't understand and who can go look at that. And so a big part of our DataDiscover offering is actually initiating that conversation between administrators and the end users of that data. We find that conversation is what actually can drive to action. Is that many times there's a focus on in the storage world of saying, oh, I'll abstract this problem away. You can store things or tier them off in an automated fashion. But in reality, that just creates unmet expectations for your users. You know, a user says, oh, I'm going to go pull this data, and it's locked away in a tape vault or something like that, and they didn't know it was going to go there. Instead, involve them in the conversation of where should this data live, and how do I go right size manage that. And so that's a conversation that is between administrators and end users, and you need something to bridge that gap, and that's what we bring with DataDiscover.
So you're basically targeting what I call unloved data, like not things that people know a whole lot about, like their IoT stuff. Like if they've got IoT, they know what it is, they know how to interpret it. You're going after the data that may or may not be mission critical because no one is currently managing, you know, separating it from the data that people love.
That's right. Is that, I love the term unloved data, is that the focus is on this, you know, I call it the unstructured data. We're bringing structure to that unstructured data so you can make decisions about it. Is that, that is the thorn in everyone's side, is that I've got this, you know, call it 25, 50% of my infrastructure that, oh, it's just, I can only just buy more capacity. I don't know what's in it. There's no agency in dealing with that data. And we said, no. Why is that the case? How are we not spawning conversations about it? Because there's huge value in either making the business decision of like, oh, that's not data we need anymore. How do you answer those questions? How do you shine a light on it and get the right eyes on it? And it's not an infrastructure problem. It's a social problem of who owns this? What's the provenance of this data? And how can I get some indicators and some archaeology to go do and understand that and spawn that conversation in organizations? So look, that's the philosophical view. In DataDiscover, it's a very delineated line of like, here's an interface for you to go browse and understand what you have by owner. Who owns this data? Is that person still with the organization? How do I start having those conversations if I just don't have visibility to see it?
Okay, so it sounds like your product can surface my data, but if it's untagged, what do I do? I mean, you just say, hey, here's a bunch of stuff, so now you can tag it, or do you provide some mechanism to help automatically do that for us?
You know, it's a little bit of both. There is certainly the like applying some sort of schema to it, either through tagging or organization within that. So we have various ways of doing the tagging or building live views so that you can monitor certain classes of data. But the point is that you've got to have that lens to look through on the data because it changes over time. So what about the new data that comes in and it doesn't get tagged appropriately? How do you deal with that? And so you need to go back to the foundations of where is the data coming from and how do I, you know, intrinsically tag it. And that's what we focused on, is how do I actually surface the queries that identify the data that you want there and have that work on with the future as well. But what we find is that it's not just building and organizing the data. Like, I think that's a strong draw. It's usually taking the action upon it. Is this data in the right place for my organization? Have I thought about how my organization and the data pipeline within my organization and its full life cycle evolves? You know, in some organizations, this is very well developed because they're a project-oriented organization. I start, you know, for instance, a chip design, and that has some sort of development cycle with it, and then I tape it out, and then it's, you know, on the truck until I do a next rev of it. So there's a very clear line within that, and there should be business processes associated with that, because it's one thing to go say, oh yeah, this data is so-and-so's, but if there's no business process around how that executes through its life cycle, then there wasn't really much effort in doing all that tagging just to say like, well, here's how much, you know, Bob has in engineering associated with his infrastructure.
I have a question too. It looks like you created a product to solve a people problem, to give the ammunition to solve the people problem. So having said that, who are you targeting in these organizations? Who do you see to be the people that can take this data and actually make a change? I know from being inside organizations, this is not an easy topic to even broach, let alone having data to broach it. So.
Look, I would say that there's two aspects of this. One is this is the vision aspect of it, and we do have the products there to go start those conversations and then are there. But there's acute problems today that we focus on as well of, hey, look, we'll get started with backing up your data and giving you flexibility in doing that, because getting a second copy is something that everyone should be able to go do, and you're not having great choices to do that today. And we bring in this visibility, and it really changes how folks operate. You know, if you look at some of the quotes that we have from our customers, it's that I've never been able to get a view of my data like this, and now it empowers folks to have those conversations. So to answer direct, oh, go ahead.
Who are those folks, though? Who are you targeting inside organizations?
You know, it comes from our world is kind of, you've got the administrative side of, hey, there's somebody who owns the infrastructure backing this or owns the bill of it. And that's where we start this is, hey, look, is this just growing and yet your budget is shrinking? How are you managing that gap? And that's the problem we see acutely of where visibility shines, is saying, well, can you go identify where actually all the growth is coming from? You know, a bit of that. And then there is also what we would call our the end users, or those who are the data owners. And they're on the other side of this equation as well. Now, that's a more desperate set. That's folks like engineers generating chip designs like I talked about, or life sciences scientists who are generating, you know, large amounts of sequencing or imaging data, or you know, in the movie industry, this is animators and all the content that goes into that, or special effects in post-production. And so it's the way in which infrastructure is what aligns all these things together. And so we you know, look, we primarily talk to infrastructure folks, but it empowers them to have a conversation. And it is a conversation, is that you need to be able to interact with this data, as opposed to say, here's your report of how much you own, or here's the line item of how much data you have. And that doesn't create actionability, is that ultimately when you're sorting through data, it's diving into the next level that answers that question. And so that's why we have built a product around the visibility that is shared between the infrastructure side as well as the end user side.
Are you going to disclose the end user side or share that with us?
Can you say more? I just want to understand the question.
You referenced the end user.
Yeah.
How are you going to demonstrate that, if possible?
Yeah, I think that you know, later on, Andy will have a demo of some of the pieces with DataDiscover where we can see some of that. But what it comes down to is sharing that interface. You know, Mike had thrown up a screenshot of what DataDiscover looks like. If you put that in the hands of end users and give them to be able to search and filter down their data, and they're the ones who know what that data is. You know, at the high level, you know what's in a system, you might know what a project is, but to get to the true actionability of saying like, hey, did you know that 80% of the capacity that is being taken up here is all intermediate files that are not business critical, and we could go clean that up? You know, in the development world, this would be like, I need the end binaries to ship them out, and I need the source code, but all the object files that live in between, those are just kind of intermediates. And yet I didn't think to clean them up. Wow, shouldn't I introduce a process in which I clean that up? Those are the level of insights that we see folks have when they have a suite around visibility to go understand what's there. Great interaction. Hopefully this helps you guys understand a bit more of kind of our model of what's out there. Getting back to the innovations that enable this, because look, I think that we can all build something where, you know, an analysis tool of what do I have, or the ability to run a copy or a robocopy or an rsync task. But if you can't do it for hundreds of terabytes, petabytes of data, then you get back to this world of, I just got another series of silos and what you have out there. So the fundamental innovations that we focused on were the capture of this data. How do I go capture, you know, 1 billion entities out there and understand what their metadata is? How do I go build an index around that can answer these questions? You know, I think that I saw a question on Twitter around how much space does, you know, 80 billion objects of metadata take up? And really that was the focus of the index, and I'll talk about that a little bit more. And then action is the key to all of this, is that fundamentally we don't get visibility to just say, well, that's great, what do I do now? You usually want to go take action upon that, and that ultimately with data is move it around, have the right data at the right place in the right tier or the right location. And so you've got to be able to do that at again, that hundreds of terabytes to petabyte scale. And so we focused on the movement aspects of this so that you were able to fully leverage the networks that you have out there. So I'll go into each one of these in a little bit more detail just to give you an idea of what did we do differently? How did we change up the equation here? And the first one is with scanning. And this is this question that always comes up. You know, I was the architect of a streaming protocol, so a change-based protocol where, hey, every time you have a change on your primary system, it streams the change to an external tool set. And at the end of the day, if you can just make scanning fast enough, there's not much difference. If I can go scan a whole file system or a whole object bucket in minutes, am I looking at this thing on a real-time perspective? Am I staring at the dashboard as it happens? Well, if you're solving a performance problem, yes. But if you're solving a data management problem, I have this breadth of data. Minutes is great, right? And so we focused on how do I fundamentally capture that information as fast as possible. And so what we did here was we wrote our own protocol clients from scratch. Is that we said, look, there's a ton of layers out there that are holding you back from your data, particularly when you're not looking at the data itself. Is that when I make a read of a file on an NFS share, it goes through a syscall into the kernel, which then makes some network calls that then has to go all the way back up that stack and again. And that's just fundamentally inefficient compared to, hey, look, what if I did this all in user space? It was just like another, network application like I have on my desktop. And that's what we did, is we did that for all the major unstructured protocols out there. And this unlocks a whole new level of things for two reasons. One is that we get a level of performance that is just not seen with off-the-shelf clients that you see out there. Number two is that we can be way more efficient, is that those layers are much different. So I'll give you an example, is that we had a customer run this. They actually told us this metric of, they ran an rsync comparing what an off-the-shelf rsync task against an NFS share versus the equivalent operation with our DataFlow application. And we did a quarter the IOPS that rsync did. Is that we just didn't do a bunch of wasteful operations that are, if you ever go look at a network trace of what happens with NFS or SMB protocol, is that it's stuttering, it says the same thing over and over and over again. And we just cut all of that out, which vastly reduces the footprint of actually needing to do these kind of sideband operations from your usual application.
Hey, Jeff,
yeah.
There's this 400K files per second per instance. What's an instance? And I assume it's all running in the cloud someplace?
So, I think of this as software. So we actually usually run the scanning side close to wherever the data is. So that would find itself in a customer's data center or in the cloud for cloud. Look, this 400,000 number is that I think of this as that we max out the network throughput of whatever instance we're using here. And that's a good, if you look at today's balance of networking, compute, and storage, is that CPUs are way faster than the networks that they sit on. And so 400,000 is basically line speed of a 10 gig instance or server, if you will. And so we can basically max out the network of just doing metadata operations against NFS or SMB or an object workflow, and that adds up to about 400,000.
Okay, Jeff,
so
jumping
Jeff,
in there.
This is
go ahead, Keith.
Quick question. I'm getting the complexity of this challenge and what you guys are trying to solve, but you guys are advertising yourself as the source of truth, but you're not real time. How are customers practically using something that's not real time as the source of truth? I understand that the target is in transactional data, but as users build applications that require a single source of truth, how do you guys reconcile conflicts after the fact?
Again, I really like the inventory management as an analogy. So if I run, Nordstrom here in Seattle, I think of what is my inventory as what's in my database. But the reality is that I've got inventory out there on the shelf, and that's what actually gets bought off the shelf. And it's the same thing with digital assets, is that we're not solving performance problems. You know, if you're trying to say like, oh yeah, what's the exact source of truth of this file as I'm trying to access it? Yeah, look, that's not the problem we're trying to solve. But if you're trying to say, I've got 50 petabytes of data, I don't need it to be, you know, real-time exact. What I need it to be is about right of what it looks like. And that's the same thing that you see in inventory management, is that, yes, there is shrinkage or terms for it. I don't know all the complexity of what the concept is, but there is going to be drift. But is it in the, you know, small percentages of what the difference is from the ground truth? That's about it. And that's what we see with unstructured management as well, is that, look, when I'm dealing with petabytes of data, is that 1% is 10 terabytes. If I am off by that much, then and what I'm saying is I'm actually off by 50%. Now we're starting to talk about it is actionable, is that stuff hasn't been touched in a year. So if you compare the time scales of what is real time of minutes compared to the years of time that I'm measuring this against, it is on the right relation there. And that's what I would say, is that yeah, it's not real time, but it's very actionable for the problems that people are trying to solve.
So it seems that one of the important distinctions of this solution versus some of your competitors is that you don't have to introduce yet another layer of abstraction that you have to access your data through. You're able to provide this functionality as an external analysis tool and not introduce that that additional silo. So maybe you can add some supporting point there.
Yeah, that's it. That's the model that we view this as, is manage your data where it's at. Is that, look, we don't look to sit in front of or in the data path, is that we want to give you actionable insights of what are there and allow you to make, you know, copies of that data and know where all the copies are at. And so the model is exactly right, is that we look to sit alongside and not get involved in, hey, look, I'm sure your application is running really well. I don't want to get involved in that. You know, there's great solutions that and give you flexibility in doing that. And so, look, we look to say that you should view these problems as I need to compose them together to have the right solution, as opposed to I've got to choose the right stack and you know, have some sort of virtualization layer in between here. Is that really this is a problem that we can do along the side, and so we should.
Jeff, just coming back to a couple of questions on the slide you got up there for AdaptiveSCAN. When we're talking about scan rates in millions of files, at this stage, we're talking strictly about the metadata structure. We're not actually scanning for content to do deep Google indexing on the contents of files at this stage, if I understand correctly.
I got to walk a line here. Stay tuned. So, you know, look, with unstructured data, there's kind of two aspects. You know, this is a great question because it comes up a lot of folks asking that. And I'd say in a couple of ways is that unstructured data, you don't get to a petabyte of data with a bunch of Word docs or Excel. You get there with imagery and design files and whatnot. And so that said, there is what I call kind of deep metadata involved in those sorts of things. So for instance, if you look at, you know, imagery files, you have EXIF data in JPEGs or DICOM standards for TIFF files, you know, various forms of deep metadata, things that are inside of those files. And you know, there's some performance considerations there of if I start reading all of these files, that's just multiplying out what my performance considerations are there. But what I'll say is stay tuned to that, is that, you know.
Okay. So, but you're talking that we're looking at the basic file metadata that POSIX-based file systems give me, plus whatever seems useful from the file standpoint. Obviously, image data comes with EXIF, and I'm sure there's other data types that I'm not familiar with that have their own intrinsic metadata points. So you're collecting as much as you can natively collect from any standard file type that you run across.
That's right. Yeah, is that we want to give you as much, you know, as much context as we possibly can.
Okay, that's great.
So there's another side of this that is pretty key, is that, you know, when you're talking about this incredible performance, the immediate question is, oh boy, that's going to swamp what I have in terms of capacity. You know, less so for the cloud, although in the cloud, basically performance concerns turn into cost concerns. But what we do is that since we have full control of these protocol clients or agents, is that we observe every IOP that we execute, and we can see changes in latency that would indicate load on those systems and can immediately back off. And so what we find is that folks can run these, very high performance scanning and indexing activities during the day, when you would consider that usually a bad idea. And so we have folks who run, for instance, backup all through the middle of their day, and that's typically not the way you would balance your systems. But we're able to do that dynamic balancing between primary workload and the activity that we do with this infrastructure. So that's great and all. I can capture millions of files per second, but it comes to this question of what do I do with all that data? If I was to go put that into a traditional database, it would grow to be very large and a very complex database problem. And that's where we said, look, we got to change up the index, or the way in which we store this information. And so when we were evaluating, look, we didn't set out to build another database out there or whatnot, but what I found was there was not a good solution out there for this problem, where I ingest billions of entities and metadata, but I query it infrequently. Is that most databases are out there for some sort of balanced workload. I have some amount of ingestion and some amount of reads, but this is hugely imbalanced. I ingest an enormous amount of information and query just a little bit of it. And so what we said is, I think that we have to focus on a different design point where we're focused on this efficiency aspect of what we need to go do there. And so we've built our own index, essentially, that allows us to capture and store this information and turn around and offer rich queries on top of that. And so, it really comes down to the details of how this is built. We didn't invent a new world, but you can think of this as based on similar log structured merge tree technology that's out there for things like Bigtable and whatnot, but designed for very high ingestion rates, but modest query rates that you'd see within an organization. So for instance, I have billions of files, but I only have, maybe 1,000 users, maybe 100 users of this data. How many queries could they actually issue against this? And so you needed to right size this. And so, the number we use here is that we do this essentially at 1% of the cost of off-the-shelf alternatives. So some things that we've compared this against, that number specifically came against what is the cost of running this index against DynamoDB and storing all of my metadata in DynamoDB versus our InfiniteINDEX, again, backed against just S3 or NFS. So we can back this in kind of a cloud architecture wherever we need it. And this is the key to being able to ask those questions in one place. So, there's no silos of what's going on in my infrastructure. Is that I'm able to say, what is all of the data that I've backed up across my entire, multi-site organization, or how old is my data across my entire organization? And we bring that all together in a single index at an incredibly cost-effective way, which was, if this costs too much, you just don't answer the questions. It's not worth it. You'd rather just go buy more storage. And so we had to change up the economics of what that looked like.
So where does this index lie? I mean, where does it reside? Does it sit in your data center? Does it sit with your cloud service provider? Both? Where does it go?
So we offer this in a couple of different varieties. We can either run it on premises, on essentially off-the-shelf hardware, and back it there. And again, the efficiency is why you can actually do this. And so, for instance, the 40 petabytes of data that a customer has, each weekly scan is less than a terabyte of compressed footprint that is required to actually back that information. So we can do that on-prem, but we primarily see folks doing this in the cloud. So we run a service for them where they can unify all this data back to a single source, because that's how their organization actually exists, is that they have data centers all across the world and they want to see it in a global view as opposed to just one particular site.
So Jeff, this is Ray. You indicate it's less than 1% the cost of the off-the-shelf alternative. So are you talking about capacity costs for those off-the-shelf alternatives, or application costs as well as capacity, or servers, or I'm just trying to get a handle on what all is involved in the cost.
Yeah, when we focused on the cost, it was actually the combination of compute and storage and the network to deliver that. So again, this was a cloud-based alternative of what was out there. On the on-prem version, cost ends up being a lot different because you've got to have a minimum unit that's out there. So, hey, I run this on one server, but what we find is that just the underlying execution of both the storage footprint, just because of the way in which we format and store and dedupe and compress this, as well as the compute, which is really focused on the streaming oriented nature of ingesting this data, so that we're maximizing kind of multi-core architectures, is designed to ingest this large amount of data. Did that answer the question?
Yeah, thanks.
So the last aspect is actionability of that data, and that comes down to movement. Is that what you find out there is when you try to move data, you quickly learn of all sorts of bottlenecks, either on where you're moving the data from, to where you're moving the data to the software you're using in between. And so I think of this as essentially a pipelining problem of how am I filling a pipeline, which is ultimately your networking infrastructure, whether you have a direct connect to the cloud on your premises, or whether you have some fiber running between different parts of your organization, is that actually maximizing network throughput of unstructured data movement is not trivial. Is that it's filling that pipeline, and how am I scheduling the work that's associated with that, reading the data off of the primary, packaging that up in some sort of format that I'm going to send across the network, and then writing that back down to a secondary system. Am I doing that in the level of parallelism that's going to actually achieve the network throughput that I need? Am I scheduling the IO against both the primary and the secondary to ensure that I don't have stalls in this pipeline, if you will? And so there's a lot of pieces that go into that we've just focused on from the history that we have of moving unstructured data. Of if I have a billion 5K files, the IO structure and how much parallelism I throw against this problem looks a whole lot different than if I have 1,000 1 terabyte files. And that is exactly the thing that is not taken into account in historical kind of data movement applications that are out there, is that they've been designed around this world of, as fast as I can read things off of the primaries, as fast as I think this thing can go. And so all the design decisions were trickled off of that. But in reality, storage infrastructure is incredibly powerful these days, is that they can deliver millions of IOPS off of single file systems. Or if you look in the cloud, I can move hundreds of gigabits per second through these systems. But if I don't have the software to actually orchestrate that infrastructure, I don't realize the outcome. And so I might want to move 100 terabyte volume, but if I choose the wrong tools today, it doesn't happen. It ends up taking 10, 40 times longer than what the back of the napkin math would say. And so the key of this data movement is that scheduling algorithm that goes and fills this pipeline for us.
So Jeff, I can see this being effective when I'm moving my unstructured data from on-prem to cloud storage. That works for this. Mm-hmm. Now, one of the things you also talk about is moving from cloud to cloud. Is there anything in IntelliMOVE that will help minimize my egress charges for moving that data? And what happens if somebody misconfigures IntelliMOVE and moves a bunch of data? Is there any way that can help mitigate those? Are there any guardrails on IntelliMOVE?
Today we just don't see a ton of cloud to cloud data movement. And when there is an intense focus of kind of the pricing dynamics that are involved there. And so I would agree with you that that's there. And look, there's some very smart economists at cloud vendors who are very much not looking to say, how do I cheat this aspect or whatnot. And so the pricing is going, if you want like for like copies moved across, you're going to have to pay the piper for that. There's nothing we can necessarily do there except for do it once and write, which we do. Where we see this more commonly is I want to load a data set up into the cloud. So for instance, archiving is a very common workload that we see that folks want to use the cloud for. I'm done with a project. I may never look at this data again, but it behooves us to preserve it for historical sakes. And that's a great use case of something like Azure Archive Blob or AWS Deep Archive. And using those tiers, if I put, all of those, billion 5K files that I talked about, it's going to incur a ton of cost and transactions. But we do have kind of a ability to put that up in a cabinetized format, or a tar file, if you will, up into those that we index individually, so you can still pull things out there. And that does optimize cost in doing that. And that's, part of kind of the IntelliMOVE activity is how we actually can group and take advantage of characteristics of cloud target storage like that. But it depends on the workload that you want to go do.
Okay, so your website has several calculators on there. Is there a calculator built in to help me determine which of those is the better option for my data? Whether it's AWS or Azure or Google or wherever.
It does, yeah. So we have the ability for you to just compare, different targets, target storage, and what the pricing models are. So we've built all the pricing models into that and take into account what your workload looks like, because you supply some of that information, and we can help size what that looks like in a comparative nature from that. There was another part of your question I think I missed there, though.
No, we're
okay. Okay. Yeah, I mean, the pricing aspects are there, and we look to help you understand what those are and really take the fear out of what the costing would look there. So we have folks who have been using this for multiple years now and taking advantage of those tiers, and they're extremely happy with the results from a cost perspective of, especially when you align what kind of data you want to store with those tiers, and we help essentially do that for them. So
Jeff, you mentioned earlier that when compared to an rsync, IntelliMOVE was 1/4 of the IOs. Is that through your? It's certainly not. It's not a scheduling aspect. It's obviously got to be something with respect to the protocols that you're using, and the internal protocol. And the second question I have, if you want to answer first, it's up to you. But you mentioned that you're actually faster than storage-to-storage replication. Mm-hmm. And that's a different game altogether. So maybe you can answer the first question. We can move on to the second.
Yeah. So the first question around
1/4 of the IOs, right?
Right. 1/4 of the IOs. If you look at, particularly in the file protocol world, what you see is that the operations that an application takes compared to what happens on the wire are mismatched. So for instance, I'll pick on NFS. If I do an open on a file, just to fulfill all of the requirements of what the kernel expects from an open file, it has to look up the path of that file. It then has to stat the file and load some of the statistic information into there. And then, there might be a couple of other actions that it does. That's before you even issue the first read of that file. And so these things are capturing a bunch of information that fulfill layers between your application and the data source itself, but had no, if you're not going to call those things, it's not necessary. And so we basically cut all of the cruft out of that interaction. And, I don't have an example here I can pull up for you, but if you look at any sort of network trace of these network protocols, is that they're just really chatty to fulfill the layers of abstraction that exist between your application and the data source itself. And so we just cut those layers out. So we only ask for exactly what we need. And that's where that duplication goes out. Now, that said, there's a ton of layers of caching within those abstraction layers that minimize the impacts of those, but work you don't have to do and don't spend time on caches in your filers and on your clients and everything in between, just gives you more capacity to do the work that you do want to do.
Okay, so that's the answer to the first question. The second question is IntelliMOVE versus replication.
Yeah. So there's a couple of aspects here, and what this comes down to is that, particularly in replication, there's different goals for replication. One is I want a true DR copy. I want to say that I can fail over my application to a secondary data center. And in that motion, you have a primary that is, maybe got some all flash array or maybe it's a flash and hybrid combo. It's very high performance. If you're doing the right thing by DR, you've got another one of those sitting ready to go on the other side that's capturing that information. And look, that data works pretty well because essentially what replication is doing is it's saying, take all the operations that happened on the primary and replay them on the secondary. That works great. Now let's look at how replication is actually being used for backup and archive. Is that, yes, I have my, very performant primary tier where I'm running my application against, but I probably am going to go lower budget on my secondary. Maybe it's some nearline infrastructure. Maybe it's some archive infrastructure, all disk, right? And when I do that, I'm taking the number of IOs that I ran against a flash system and I'm trying to replay them against a secondary system. That's going to be a problem because it can't perform at that same rate. And the problem is that I'm doing so many IOPS now on my primary system is that I'm not even able to keep up in writing that data in the same way that it was written on the primary. And so that's where this problem becomes and breaks down for replication, is that I can't replay what happened on the primary on the secondary. That's the way that these things are done. It comes back to this streaming or real-time model.
Jeff,
Yeah.
a lot of the replication solutions out there for archive or DR are asynchronous replications using snapshots and many times it's changed data that gets replicated across not the actual IO activity, although you could argue that it's more or less equivalent. And sometimes it's actually compressed and or deduplicated data that's getting replicated across. That's going to reduce the number of IOs, the amount of data transfers that's required, and that sort of thing. I mean, how do you, IntelliMOVE, it looks to be, a replication of the actual data with less IOs, as far as I can tell. It doesn't deduplicate the data before it moves. It doesn't compress the data before it moves. I don't know that, but I'm asking the question.
For IntelliMOVE, we do focus on the movement aspects, but we absolutely do compress and compact that data down to its minimum footprint. And that is a big gain on what you see in replication. So when I talk about replication, it is, the snapshot-based diffing that you see out there, and it's creating the like for like. And that is where there is a meaningful difference between that and using it for backup or archive versus, something that's out there. So, when I look out there, I don't see a ton that's going and taking advantage of great compression rates that's compacting large amounts of this data. And so where you see, for instance, the claim that Mike talked about, a 40% reduction, is that it actually comes through pushing these things together in very large chunks and then individually cataloging them or indexing them in that fashion. And so getting the compression that's out there is something that just hasn't been brought to real unstructured data. I think that there's certainly marketing that would say that out there, but people aren't realizing the results of that. And what we're saying is people are actually realizing the results of strategies that have been talked about for a long time, but they're not able to be put in play because they're not high enough performance or high enough throughput out there. I'll give an example of that is that, look, a traditional backup writes a backup stream that, compresses and dedupes and whatnot and lays down to disk very well. For 1 billion files, how long does it take for your catalog server to catch up with that? The answer is it doesn't. And so what we're saying is that no, and what that does is that drives people to not use that because I can't do a granular restore anymore. Is that I've actually lost the ability of saying, look, I do have a fully indexed copy of my data, but it's nice and space efficient. Is that we're saying, no, we actually offer the ability to do both. And so the thing that we're identifying here, and maybe it's not coming out too clear here, is that, look, you're right now having to choose. You either get that in-depth ability to understand and index what I have, which is a file system, which is what we see in replication, or I get a blob that lives on disk that I can't actually individually pull back a file or understand what's in it. And so it's the farthest thing from a file system. I can't get granular use of it. And we're saying, no, we do both of those, which means you get the granular level insight to that compared to replication, but it sits at a footprint that is a fraction of what's out there.
All right, thanks.
So bringing all these things back together, it really comes back to what I talk about is scan, index, move. That's what we do when we talk about data management from the underpinnings of what this can go do. And we do that across all of these different protocols and platforms and clouds to be able to go do that. So this technology is not tied to one particular protocol or way of doing things, which is really key in my mind, because I want to be able to see all of my data, not just the ones that live in this platform or that platform. So bringing this all the way back around and full circle to kind of the products that we offer is that, look, DataProtect, which is backup and archive, that's scanning for change, moving that data and indexing it. When you look at DataDiscover and we talk about visibility and shining a light on things and then sharing that within your organization, that's scanning and indexing that data. And then just moving data around, either for purposes of, space efficiency on platforms or moving things to the cloud, it's scanning that data and moving it. And so this is the underpinnings of everything we do from a product perspective. And hopefully that comes through in that. So that's, again, the ways in which we are able to do these massive sets of data movement and backup with the high performance. It's how we're able to do the search capability and the visibility capability across multiple petabyte systems. And it's the way in which we can move massive amounts of data either cloud to cloud or from NAS to NAS. Any final questions I can ask or answer?
Yeah, this is Calvin Hendricks Parker. I got questions about the Discover with this sheer amount of data and it being unstructured. I mean, I think the indexing, the scanning, the gathering that metadata together sounds like it makes sense. I still don't know how your users are going to make heads or tails of a lot of that data. It sounds like the people who are administering it may not know what that data is. They're kind of relying on their users to know what that data is, but a lot of their users may not be savvy enough to come into the system and properly take care of their data, or if they were, they would have done it anyway. So is there something else going on in DataDiscover that helps them to do that?
Look, it's about a clean presentation of what they're looking at. So, the ways in which a user might go try to understand their data is that they would go run some find command on their filer and dump a bunch of data into a CSV file and then try to think about something that's out there. That's a lot different than an application that's purpose built for answering the question of how old is this data? If I search for this type of data, how much of it is taking it up that space? Oh, wait, it's actually all just in this one directory. So it's an exploratory process, and it's that interaction with the data that really drives to the answers for end users. And, look, I know that a lot of what we say here sounds very aspirational, but I'll tell you is that our customers, when they first see this, is that you can go sign up for a demo or running this application with your environment, with your data. They're like, I did not think this was possible. I just didn't. There's been so much time spent on saying no, you just can't get a view of all your data. That's going to be way too expensive, or, it's just not possible. Yeah.
You're making it sound like that's a pretty low bar, it seems like. I think as these data sets get truly large, just finding a large directory full of a bunch of files, that magic seems to be, I don't know, it seems like a pretty low bar. Is there something else you're helping them do to understand that data?
There is that, we are working towards surfacing more insights of saying hey, did you know that your growth has primarily come from things that match this pattern? And so those are some of the things that you'll see come over time with this product space. Right now, look, I'll tell you, whenever I go ask somebody how much data do they have, their number one answer is how much storage they've bought. And so I would say that, look, it is actually a meaningful question when you're talking about petabytes of data of, no, how much data do you actually have? And people just can't answer that today. And so, I think that you could answer that in the past in various sort of ways, but you can't build it into your DNA of managing this data of going out there. So I'll plug one place to go look at this, is that Chris Dejian gives a great talk at BioIT every year of data from the trenches. And he talks about this problem very eloquently about what does data management actually look like, and what does it mean to actually make these changes within an organization. And I think that's a great summarization of just some of the basic maintenance that needs to be happening, not just at the administrative level, but all the way down to your end users, and helping them make better decisions about managing their data.
I think the other thing I'd say is there's two fundamental use cases around the storage of unstructured data. Most of it, and a lot of the growth, is coming from the AI, ML, and the compute side. There are some that are just retention based. And so medical imagery, things of that nature, and there is data reuse and analysis, but you always want to have access and granular access via that index, as Jeff pointed out. And so I don't want to just gloss over the fact that high performance compute in the bio IT world, in the chip design world, and the reuse of data via the index and the faceting and the recovery and repackaging of data and the movement up, the generating of a work set into a compute environment, the operations upon that, and then the protection of that through the iterative recursive schemas of trying to seek many iterations of condition improved or result sets. And so if you pull back on the minutia of all of the methodologies and the systems that we're delivering, what we're driving to achieve is a place where you can very rapidly inventory and facet all your data, automate and construct workflows that go through compute and or retention automations, and continually analyze and improve those processes and achieve a condensed state of improvement sets in a shorter amount of time with a higher quality at a cost basis that doesn't drown you. And so there is a lot of money being invested around AI, ML, and the process and iterations of learning. And we're just participating richly in the unstructured data side of that, if that makes sense.
So would you say then, because I keep going back to customers and who's the consumer of this and who you're selling this to.
You bet.
So when you keep talking about unstructured data, so if we take that in the traditional sense, which I'm going to take at face value, that's what you're talking about. And now I totally understand what you're talking about with ML, with that data. Is that the market y'all are chasing? Is that that's your primary market, or who is your primary folks you're selling to?
So I would answer that. I think the easiest to illustrate is through verticals. And so it's the entertainment for the generation of animations and things of that nature. It is the bio research or just the research side, whether it's bio or not. And so there's tremendous high performance compute cycles going on into that. There is the chip manufacturing or the complex manufacturing side of things. And so it is relative to the world's data owners, when we slice it down to unstructured data, it is a much narrower type of corporation that has this issue. But the benefits or the risk reward in those deep, rich verticals around unstructured data is, you're hearing conceptually all the limits around the topics we've been talking about. They're pretty far behind the structured data side. And it's the nature of the complexity of the solutions that have to catch them up to parity. And so, I think it's best explained in that regard. It doesn't exist everywhere. And now when I say that, if we come off the compute environments on the AI ML and we start to talk about only retention, school districts are now required to retain video surveillance for access for quite some time. And those video, depending on the size of the school district and the number of cameras, for instance, pretty soon you're talking about multi-terabyte, and you can get close to 500 terabyte images. And so what that's saying is it's not this highly specialized corporate types that benefit dramatically from what we're talking about here. Everything else is coming up behind it on simple things of retention for medical images, that the data sizes, because of the richness of the imagery, is big. And so it goes into a collective unique store that from that index can be accessed again simply. And you don't have to pull back a blob and parse through it all to get one specific patient's imagery. You can go in through the index and pull that back. And something as simple as a retention or a document image for a law firm. And so the size of unstructured data is starting to democratize to a school district, not just a bio research firm. And so
that makes a lot more sense to say you're starting with that HPC, which is also ML, DL, AI type of architectures. and then looking at other places. So that's very helpful. Thanks.
Yeah, 100%. I mean, financial services are in here for trading analysis. And so if you think about an unstructured data set or, high volume data that you can crush and run through improvements and recursions on, that's the tip of the spear. But this problem exists in school districts. So,
Okay, so I'm sorry, I think I missed something. You said that you can actually, you're able to access the data through the index. Is that correct?
That's correct. Yeah. So we index and identify where all the data is located at.
Right. Okay. So at some point, how do I point my applications and other things to point to your index as a retrieval source than my S3 bucket, say?
So that comes in a couple of forms. One, we don't traditionally suggest having an access through us. Typically, the model is that you would pull the data back to wherever you want to process that data, because look, running the application against an index that's not designed for your primary workload is probably not the wisest idea. And so, moving the data back into place to where you want to process it is probably the most common form in which we would have folks do that. That said, yeah, you can access the data directly through our platform as well.
yeah. So you find it quick, you excise it, and you pull it back to how you want to view or use it. And you wouldn't use us as the process of, reading the medical image, if you would use that analogy.
I'm not sure who to ask the question to, but data protection is more than just copying data. I mean, snapshotting, being able to do different styles of restores, extracting files or emails or, gosh, that sort of stuff. I understand that you can move the data effectively. I understand that you could certainly index the data, but, indexing the data that's existing in some unstructured infrastructure and maintaining a catalog of what's been backed up over the course of, months, years, or whatever, are two different things.
What I would say is that, look, we have all of those underlying aspects of what it means to protect the data. I think that what we wanted to just talk about was the thing that's been failing in backup infrastructure is the scale to go do that. Is that I can have all of those rich features, but if I'm not hitting my SLA, it doesn't matter. And so we have a large amount of exactly what you're talking about, the ability to granularly pull back, to investigate exactly all the snapshotting, all the snapshot integration, all of the integration with filers. We do all of that. I was trying to be mindful of time here and focus on the pieces that are really key to actually being successful at doing this.
Yeah, so most people, when I've talked about these sorts of problems in the past, you can back up 100 terabytes or 200 terabytes or 500 terabytes. When you start talking petabytes, people don't typically back those sorts of things up. I mean, they might replicate it or they might mirror it, but they're not backing up 40 petabytes of data.
Mm-hmm.
Are you saying that you can do this sort of thing?
Not that we can, that we do. With our customers today, that's exactly the problem they're looking to solve, is that I think that the idea of backing up petabytes of data was relegated to replication as the only thing that can solve it, and that's what drive you to that solution. And what we're saying is that with technologies around our index and doing things like incremental forever, we can retain that copy. Now, the question of what footprint size do you want to maintain that copy could be a conversation of retention and various other aspects, but we're saying, yeah, absolutely, we back up and regularly do protect multi-petabyte, 10 petabyte environments.